Hi, folks. This is Stan Forrester. This week we're still talking about optics, geometric optics. One of the most intractable problems of the Manhattan Project, the creation of the first nuclear devices, was the implosion problem. Okay, at first they thought that they could just slam two masses together, compress them, get that critical mass, and create the fission explosion, the chain reaction. Turned out it was a little more complicated than that. They needed to take a mass and they needed to compress it uniformly. Now, if you took explosives and wrapped it all around it, what happened is you got this compression, but in different spots, and things would squeeze out all over the place. And that's basically all that happened. Okay. And it was John von Neumann who figured out that you needed to initiate the explosion so that an entire shell around around your pit. They called the fissionable material the pit. The pit had to initiate simultaneously. Now, how do you get that to happen when you initiate the explosion from individual points? And here we're going to apply uh, basically refraction, what are called explosive lenses, the same kind of concept. And I'm going to need to turn that off because I'm recording right now. Thank you. Okay. Sorry about that. Okay, so from the time we initiate the explosion, we have TF. This is the time that it takes for the wavefront of the explosion to expand in the high velocity explosive. Okay, so we have T2F, T1F, and T3. These all take place in the high velocity explosives. Now, if we go ahead and shape the low velocity explosive in such a manner that the time it takes to propagate through the slow explosive, T2S, T1S, is such that the sum of these times to reach the surface of the pit is equal, well, then we're going to have a uniform compressive explosion. Now, it's a whole different idea of how do we get these points of initiation to all um, begin exploding at the same time. That was a whole separate engineering equation, but nowhere near as conceptually difficult as this problem right here. Notice here that, okay, so the time it takes for the explosive wavefront to travel through along this path here, T3, is the same as it takes to go through the fast explosive and the slow explosive along path 1, and from the fast explosive to the slow explosive along path 2. All of these path lengths are of equal time. And that's just the idea.